Hi, and welcome to a new 3DEqualizer4 tutorial. This time I will demonstrate the functionality of lineup controls. During this course we will learn how to import line geometry through an OBJ file and align a camera to this geometry. Further, it is demonstrated how single survey data can be extracted out of the geometry as well as assigned to it. At first we need to import a shot. So within the Attribute Editor's Camera tab, let's click on Browse. And within the Tutorials folder, select Shot STA for importing. Import buffer compression file. Now, let's have a look at the shot. The camera moves on a dolly from right to left, while panning from left to right. Okay, our preparations are done. Let's switch to lineup controls using shortcut F5. The main part of lineup controls is a 3D space displaying an imported 3D model, as well as the shot. With the left row of buttons, we can line up this model and will be demonstrated in detail later. The right row is nearly identical to the buttons found within manual tracking controls, and set how points and models are displayed. So, to have something to line up, we need a 3D model. Therefore, we will import an OBJ file. Right-click on Point Group, Add New, Import OBJ file. Select File, Survey, Tutorial Set for importing. As we can see, within 3D Orientation controls, a 3D model was imported. This 3D model is a reconstruction of the set containing all those things we see in the shot, like the ladder and table, as well as the marker represented as locators. Now, let me demonstrate how to navigate within lineup controls. Regular display area navigation is done using middle and right mouse buttons. The middle mouse button moves the footage along X and Y axis, whereas with the right mouse button we can zoom in or out. As we can see, the 3D model is anywhere but not within the display area, so let's center it using button Center Models. Okay, the 3D model is now visible, and you may have noticed, centering the 3D model moved the camera. Within lineup controls, we are looking through the current camera, therefore lining up doesn't translate the 3D model, it translates the camera. Translating the camera within lineup controls is very similar to navigating within 3D orientation controls. Shift and middle mouse buttons translate the camera along X and Y axis. Shift and right mouse button translate the camera along Z axis. Rotating can be done using shift and left mouse button. The camera now rotates around the virtual target point. A second mode how to rotate can be set in Options, Rotate Camera. After selecting Nodal, the camera will rotate around its own position. For this course, the previous mode is more suitable, so let's change it back to around target point. Before we start lining up the camera, we need some tiny preparations. The image plane is a bit disturbing in front of the 3D model. Let's scale the camera object to move the plane behind the model for a better view on it. Within the Attribute Editor, tab 3D Model provides options and parameters how to render geometry. This can be set for each model individually, so select the imported 3D model to activate these parameters. Now, we are able to change the model's appearance like color or opacity. Especially a different opacity can be useful if there's a very complex model containing a lot of points and lines. Reducing the opacity leads to a better visibility of the model and of course the footage. If the model contains polygons and not only line geometry, activating toggle button Show Polygons enhances their visibility. In our case, the polygons on the box, monitor and table are displayed much better than before. Option Hidden Lines is activating by default and, as the label indicates, hides all lines which are currently covered by a polygon whose rendering will not be affected by this option. As we can see, all lines behind the table, the box and the monitor are visible at the moment. But to avoid any irritations, we leave this option activated. Every imported model is stored within the 3D project file. If you have a complex model with a huge file size, it would be advisable to set this as a reference to avoid a huge size of the project file. But since our model is very small, we can leave this option unchecked. The last thing to do before we start lining up is setting the correct film back size. Since we have knowledge about the lens, let's select tab Lens and set film back height to 1.48 centimeters. Alright, everything's done. We can start now. Aligning the camera to our 3D model can be done in two ways. Either we can translate the camera using shift and mouse buttons as we did before until it matches for this frame, or we can create 2D tracking points to extract survey data out of the 3D model. For doing this, lineup controls provides three opportunities: extract vertex, extract line, and extract polygon. The shortcuts for these buttons are V, B, and N. The most common method for extracting survey is extract vertex, since these vertices can be identified within the footage very precisely in most cases. So let's activate it using key V. Now, every time the mouse cursor is over a vertex suitable for extraction, this will be indicated by a cross. Having a look at the 3D model, we see this edge of the model must be the edge of the table in the shot. So let's assign this vertex to the front table corner. Holding down Ctrl key while clicking with the left mouse button creates a new point. With the mouse button still pressed, this point can be dragged immediately on a feature. In our case, let's click drag this point on the table corner. As we can see, survey data was extracted out of the vertex and automatically assigned to the new 2D tracking point, thus converted to a lineup point. The 3D coordinates of the 3D point are identical with the vertex position. Now, when the camera is translated, all movements are consistent to this lineup point. Okay, that's all. We created our first lineup point. It's pretty easy, right? But one point isn't of course sufficient for a good lineup. This can be achieved with at least 3 points, so we will create some additional points on the table corners and the wall. And since we have so many features and vertices available, we will create more than 3 points to demonstrate the various functions of lineup controls. Again, Ctrl left click to create a point. As we can see in 3D orientation controls, extracting and translating affects the camera position in 3D space. The more points we have, the more accurate the camera is aligned. So let's repeat this with some other points. Alright, with a few points extracted out of vertices, we roughly lined up the camera. In the next step, we like to extract survey data from this marker on the box to get more survey for enhancing the lineup's accuracy. This can be done using extract polygon, but as we can see, the camera isn't aligned properly yet, so extracting from this polygon might not be a good idea at the moment, since the extracted survey data won't match with the true 3D coordinates of the marker. To achieve a more correct lineup, we try to align the camera with the help of lines in the model. Activate Extract Line and Ctrl left click to create a point. The 2D points can be overstretched like a rubber band for a more accurate alignment of the camera. Maybe another point on the box or overstretching the existing points would be helpful. A little overstretching here, a little overstretching there. As we can see, there must be something wrong since the lineup won't match with the shot. We'll consider this problem later, but one hint so far, it might be false focal length and distortion values. But for now and for demonstration purposes, we will continue with the current settings. So let's concentrate again how to extract survey out of the polygon. Activate Extract Polygon and create a point in the center of the marker. As we can see, the 3D coordinates were extracted from this polygon and assigned to a 2D and 3D point. Since we don't need the other 2 points on the box anymore, we can delete them. Due to all the adjustments we made to align the camera, the 2D tracking points are far away from their respective lineup points. In case the 3D model and the footage were matching now, it would be good to move the 2D points back on the features without modifying the lineup. Lineup Controls provides a script for doing this. Let's select Edit, Reel in points current frame, and the 2D point is moved back. Great, both points are matching again, so let's do this for the other points as well. As I mentioned previously, a false focal length and distortion value might cause the incorrect alignment. The differences of the alignment's accuracy between the table and the locators on the wall indicate this. In the next few steps, we will adjust focal length and distortion to enhance the alignment drastically. But first, we have to make sure that every 2D tracking point is placed on its respective feature as precisely as possible, having a correct tracking for starting the adjustment. Okay, every point is placed correctly. Now, let's have a look at focal length and the deviation value within Deviation Browser. Modifying focal length within lineup controls modifies the camera position as well to keep the deviation low. This results in a strange vertigo effect. Modifying focal length in the lens attributes keeps the camera position and deviation untouched, so no strange effects here. For a good alignment, we will continue adjusting with the focal length slider with the lineup controls. Every time focal length or distortion are modified, the deviation will be roughly calculated, indicating if the set values suit for the shot or not. This helps fine-tuning an alignment, since very wrong values of course can be seen with the naked eye. For a more precise adjustment, just click right or left beside the knob with the middle mouse button, depending in which direction you want to adjust the value. Alright, 25mm seems to be quite good, and as we can see, the alignment was already improved pretty much compared to previous results. Okay, so let's adjust the distortion as well. Due to the distortion, ladder and marker of the 3D model and the footage do not match very well. The ladder in the footage is a bit curvy. Adjusting the distortion value should fix this. Oh no, wrong way. Yeah, better. As we can see, it looks much better than before. Let's have a look at the full frame. Well, it definitely looks much better than before, and even the deviation decreased pretty much. Since we're satisfied with the results, we of course should not modify it anymore. Since lineup controls do not have an undo stack for lineup modifications, it would be pretty bad changing something which, as we all know, can be done faster than we think. But there's still a way saving this result in case something was modified accidentally. Button Store Pose stores the current lineup of the current frame. The frames which are stored are colored red within the time slider. Please note that Store Pose stores the lineup just for this single frame. Now, if we modify the lineup and realize that we messed up everything, button Recall Pose recalls the previously stored lineup. Okay, we line up the first frame, but this was just the first frame. For reconstructing the camera path, we need to line up the camera in some other frames as well. Luckily, the camera movement within the shot is very linear and smooth, so 3 more frames should be sufficient. The last frame and 2 in between. Let's continue with the last frame. A quick lineup using shift and mouse buttons. To align the camera using a 2D tracking point like we did before, simply left click on the 3D point and drag it to the correct feature. Perfect. Let's do this with the other points as well. Unless in manual tracking controls, another point can be selected while the selection of the previous point is still active. For moving a 2D point around or creating it when its respective 3D point already exists, simply left click on this point. Since we set the lineup in this frame just once and won't modify it afterwards, we can skip Store Pose for this in the following frames. The lineup is set within this frame and won't be affected by aligning it in other frames. Of course, just as long as parameters like focal length and distortion are left untouched. Okay, let's continue lining up in 2 other frames anywhere in the middle. Which frames are the best for such a rough lineup depends on the shot. Due to the camera movement in our shot, frames approximately between frame 40 and 60 might be a good choice. Since focal length and distortion are adjusted quite correct, lining up these frames can be done quickly. Just a few more alignments, we're nearly finished. The light at the end of the tunnel is already visible. Okay, we aligned the camera in 4 frames and got a camera path, but as we remember, the camera movement in the shot is quite smooth, while this path, well, it's not. Let's open the curve editor and have a look at the position and rotation curves. Config, add horizontal pane, curve editor. Let's select all pause rod curves. All CVs of the curves are flattened, which causes different translations and rotations than we find in the shot. So let's select all CVs and smooth the tangents. There it is, the camera path looks much better. Playback the shot to watch our results. In just a few steps, we roughly lined up the camera, but as we can see, the alignment is really very rough. To enhance the results, we will track some points throughout the entire shot in the next steps. Let's switch to manual tracking controls and create a 2D tracking point on a marker on the wall using Ctrl left click. Since we will track a marker, tracking mode should be set to marker. Couch marker and track. Okay, we're having a point tracked throughout the entire shot, so we can switch back to lineup controls. As we remember, previously we created a lineup point extracted out of the geometry which was assigned automatically to it. Existing 2D points can be assigned to survey data as well, using the same buttons we used earlier. Activate Extract Vertex while the new 2D tracking point is selected. Now, every time a vertex is found to which the point can be assigned, a dotted line indicates this. But it's pretty obvious which vertex belongs to this point, so let's assign it to the locator beside it. Perfect, the point was assigned and converted to a survey point. The 3D coordinates of this vertex were extracted to 3D points, as we can see here. By the way, assigning a point to survey can also be done within 3D orientation controls. So let's switch to it. Button Extract Vertex can be found here as well and does the same job like in lineup controls. Again, every time the mouse cursor is placed over a suitable vertex, the cursor changes to a crosshair to indicate this. But we don't want to mess up our lineup, so let's assign it back to the correct vertex. And go back to lineup controls. For a good solve, we should track at least 2 additional points. In this case, points on box and wall would be the best choice. Both points are a marker and visible throughout the entire shot. Let's start with a point on the box. Select the point and switch to manual tracking controls. Now, set the point's tracking mode to marker. If a point was tracked throughout the shot, it should be converted to an exactly survey point. Lineup points will not be considered when calculating the project with CalcOut from scratch. As long as we do not calculate anything, it wouldn't make any difference, but it is still advisable to label lineup and tracking points differently to avoid any confusions. We earlier set this frame as a single keyframe, so we have to modify the point to a start frame. Couch marker and track. Since we manually placed this point in several frames within the shot, we created several keyframes which might not be very precisely. For a clean 2D tracking, let's delete them using Edit, Delete Curve, until end. This procedure should be repeated for the second point as well. Delete curve. Exactly surveyed. Marker, endpoint, gouge marker, and track. Perfect. Back to lineup controls. Due to the existence of tracking and survey data, the current camera position and rotation can be calculated by button match frame instead of lining up manually. Please note that match frame will calculate this for the current frame only. Matching all frames would take a long job doing it this way, so it would be great having something that does this annoying job. Luckily, there's a script for it. Let's select Calc, Match Frame All. The camera path looks similar to our rough alignment in the previous steps, but it was improved pretty much. Let's play back to watch the results. The camera was reconstructed and is all in all working for this shot since we did a rough alignment. Of course, the result can be enhanced further by tracking more points, but for the demonstration purposes of this course, the result is pretty sufficient. As we saw, lineup controls provide some useful features to reconstruct a camera. With just a few points created in place with a single mouse click and a few keyframes, we extracted survey data out of an imported geometry to line up the camera throughout the entire shot. Well, that's all. Thank you very much for watching, and I hope you enjoyed this video.